Okay guys, next syllabus point, it's a large one. Conduct qualitative investigations using flame test, precipitation and complexation reactions as appropriate to test for the presence in aqueous solution of this list of cations and this list of anions. Okay, so 3 processes: flame tests, precipitation and complexation reactions. Precipitation and complexation reactions I've grouped together. So first we're just going to talk about flame test, and we've already done that in module 1, remember, of year 11, where we talked about the structure of the atom and how electrons are absorbed and emitted. Okay, so qualitative tests, I've just given an overview here. Qualitative analytical chemistry determines what chemical species is present, but not how much is there. This is quantitative. Okay, most qualitative tests are easy and quick to perform. So flame tests and these precipitation reactions, very quick. Okay, flame tests and precipitation reactions are what we're going to look at. We're going to put the complexation in with the precipitation because it's quite similar. So the type of questions that the qualitative test can answer are things like, does this solid salt contain copper? Is there silver in this solution? Is there phosphate in this detergent? Okay, questions like that, not how much though. Okay, so flame tests. Okay, remember module 1, our Bohr model of the atom, we have the nucleus in here, and we can have, we can heat up an element so that electrons jump to an outer shell, and when they relax back down, they will emit a photon of light. Okay, and since those electron orbitals are quantized or at a certain energy and distance, the energy that's emitted through this photon or light is set. Okay, it comes at a certain wavelength only. Okay, and so what we end up getting is a visible spectrum that contains spectrum lines for every single element. Okay, hydrogen, helium, lithium, and so on, all down here. Each one is the spectrum for these elements. Okay, so that's when the spectrum is split apart using a prism, or when we used hand spectrometers, we saw it split apart. But remember, all these little lines, when we observed with the eye, all these little lines are added and averaged together into just one flame color. Okay, an average of them, an average visual to us. Okay, so for example, the copper, have we got a copper one here? Yeah, purple, green, all that. Those all add together to show a flame just like that, just like a greenish color. Okay, so let's quickly talk about the methods that we use. There's a few different variations on this method. Okay, so inoculation loop, or the metal wire, dipped in the solid salt that contains that cation, that metal, and then put over the flame. In between, it's cleaned with hydrochloric acid, and so it oxidizes any of the metal on there and gets rid of it into solution to eliminate. So we eliminate cross contaminations. Okay. Another way you could do it is a saturated solution of the salt is sprayed through the flame. That works quite well. It's very effective in identifying the color. You need a lot of the salt though. Another way you can do it is soaking a paddle pop stick in a saturated solution of that salt. Okay, it's very effective for identifying the color. You need a lot of analyte. You also get some burning of the paddle pop stick as well, interfering with it. So that's a little disadvantage with that method. So flame tests are fast and simple to conduct with a Bunsen burner or blowtorch. And you can use a hand spectrometer to view the flame for verification of that expanded spectral lines. You'll see those happening. Okay. Disadvantages to these flame tests are you can't test for anions. Okay. They don't give out light in the visible spectrum, so we can only test it for cations and for some of them as well. So mainly metals. Okay. Well, all cations have different spectral lines. Some may appear of a similar color to the eye. Okay, So they each have their own spectral lines, but some of them look fairly similar to each other. So visually, you might be confused between calcium and sodium, say, because they're both reddy orange. Okay. To get around that, hand spectrometer, look at the whole spectrum. Okay. It's only going to work really well if you have a pure salt. If you have mixtures, you're going to see all these spectral lines added together and in a big confusion. Okay, and so it doesn't really work when you have a mixture as much. If you have a mixture and you're getting all these spectral lines together, it's pretty impossible for a human to determine what's there and pull it all apart. Computers can probably do it though, and you can program a computer to do it. But let's stick to pure substances. Okay, here I've made a table of the cations that are on that syllabus point. Okay, these cations that they've told us we must know. So I've put them all in a table and I'm showing you the flames. Okay, I'm describing their flame color and there's an image there too. So barium is a pale apple green color. Calcium is an orange red color. Magnesium, no visible color. You cannot test for magnesium using a flame test. Okay, that's why I put it in bold there. Lead, I wouldn't want to do it myself. It's too toxic, but let's write it in there. Let's take their word for it and the photographer's word for it. It's a light blue-grey colour, and there's an image there. Silver, you can't test for using a flame test as well. You won't get a visible colour. Copper, you get a blue-green. Yeah, like that one. Iron is gold when very hot and bright blue-green to orange. Okay, I would treat iron as being this color, whether it's iron 2 plus or iron 3 plus. You're just getting an orangey, goldy brown color. Okay. All right. Some nice simple past HSC questions. Notice they're very early on in the multiple choices. Okay, they're some of the simple. They're nice simple. Do you know this or not questions too. So what flame color is produced by barium ions in the flame test? Barium was up the top. You're getting a pale green. So that one's C. Which of the following cations can be identified using a flame test? Okay, we saw earlier that magnesium can't. Oh, copper we definitely know can, and we didn't mention zinc or aluminium. Okay, so copper is that blue-green. In my terrible writing, what flame color does copper produce when heated? Blue-green. So some nice simple past paper questions there. Okay, I'm going to leave it there because that's pretty much for flame tests, okay? There might be questions about safety there, so you're going to have to talk about the hazards of using a flame. You might talk about the hazards of, for example, testing for lead, okay? But other than that, method, advantages, disadvantages, and what you expect to see are most common questions. All right, we'll talk about precipitation next.